All right, number 18. So here you're going to do the general symbolic solution for the net force on Q3. So draw the vectors, label them, and show the components, and come back. Okay, so there are two vectors. The force on 3 due to 1, and the force on 3 due to 2. And those vectors are at a 60-degree angle to the x-axis. That's the trig that we did in the last problem. And so the x component of F31 is this, and that's going to be cosine of 60 because it's adjacent. And the y component is going to be this times the sine of 60. And this is going to be the same way, only this y component is negative, and so you can see that the two cancel. So let's now proceed and find the net force by adding those components. So the vector is k times the two charges, which are both q, so q squared. Remember, the capital Q is a quantity of charge, not a charge name. And the distance is the side of the equilateral triangle, so s squared. And so when we take, to get the y component, we're going to take the sine of 60, which is the square root of 3 over 2, 0.866 something, times kq squared over s squared. And the cosine of 60 is a half. And so this vector, square root of 3 over 2, negative square root of 3 over 2, the sum of the y components is 0. But these two x components, which have a length of 1/2, k q squared over s squared, add. And so the net force, the sum of 2 halves, is simply 1 kq squared over s squared. So that's the general solution. Pretty simple because of the high symmetry of the problem. So 19 is barely a variation on the previous one. Draw in the two vectors and then see if you can figure out which arrow shows the direction of the net force. So make sure you drew this correctly. The force should be along this line, and this is a positive charge, this is a positive charge, so the force of this charge on that one is along this line in that direction. And similarly, this is going to attract, so it follows the line. So be careful that you drew those along these lines. That's the action line of the force. These two vectors should be equal. As in the last problem, the two y components are going to cancel because the angles are equal, because the triangle is isosceles. And this has an x component, which would be about that big, and another x component, and when they add, they would give us a vector like that. Since the angle is steeper, the actual result is less than it was in the previous problem. So it's along D. Okay, here's the figure. You're asked to find 4 different forces. The 3 forces on X caused by W, Y, and Z, and 1 force on Y caused by Z. And the charge here we're given is plus Q. Here we use a little q, that's what's given. So I'm leaving that there, and go ahead and answer it. All right, I've decided to change the little q to a big Q because that's what we've been using. Okay, the first 3 are easy. The distance is d over 2, so we have to square d over 2. And that gives us 4. In other words, the force is 4 times stronger than if it's the full distance. And the full distance d is z acting on x. And so the coefficient is 1. We usually don't write that, but I wrote it here just to be explicit. Okay, this one is a little harder because this is the distance. So the two charges are going to be kq squared, but what is that distance, and what do you get when you square it? Okay, so this is a half, and this is 1, or d over 2. We'll leave the d out. Call this 1, call this a half. We've got a half squared plus 1 squared. That's going to be 1/4 plus 1. So that's 5/4. That's all under the square root. When I take the square root, I get the square root of 5 over 2. So that's a little bit bigger than 1, right? The square root of 5 is 2.2 something. So that makes sense. Now, if I go to Coulomb's law, I have k, two charges, q squared over the square root of 5 over 2s squared. So the 5 squared, the square root of 5 becomes 5. This becomes 4, so 5/4 in the denominator is a coefficient of 4/5. Now notice how that makes sense. Don't just stop there. Think about it. If the distance is d, the coefficient is 1. So this is a little bit longer, so the coefficient should be less than 1. Yes, 4/5 is less than 1. So that makes sense. Now to get the angle, let's even get the angle. So the inverse tan of the opposite 1 over the adjacent 1/2. So that's the inverse tan of 2. That's the angle there. Because I didn't even draw the vector, right? The force vector would be like that, along that line. So that would be the angle. It's 63 point something degrees. All right, number 21. This one has numbers, but I'm just going to do the general solution. And if you have the general solution, you can certainly do the numbers. So see if we can do the general solution first. So the angle's 45 degrees, and so the y component is going to be sine, the x component, well, sine and cosine, it's 45, it doesn't matter. They're equal to each other, and it's equal to the square root of 2 over 2, or 0.707. So when we take this vector, which has a coefficient of 1/2, and we multiply it by the sine or cosine, those two components are going to be equal. Square root of 2 over 2 times 1/2, you get the square root of 2 over 4, and that's the magnitude of each component. Now you want to add those to get the components of the answer, and then a little bit more tricky is using the components to get the magnitude of the answer. See if you can do that. Okay, this is probably more algebra than you want to do, and I won't ask you to do this on a quiz, but the x component is going to be the 1 minus that square root of 2 over 4. Right, so I'm taking the 1 and I'm subtracting the square root of 2 over 4. That's the component, the x component of the answer, a little bit less than 1. And the y component is going to be the same. And I can simplify it that way. I don't know if that's simpler. But to square this and square that and take the square root may seem impossible, but remember that if this is s and this is s, this is the square root of 2 times s. So the answer is simply the square root of 2 times this. It's bigger than this, the side, by the square root of 2. You can follow that. If not, believe me. So the square root of 2 times 1 is the square root of 2. And the square root of 2 times this is 2 over 4, which is a half. So the square root of 2 is 1.41 something minus a half. This comes out to be 0.9 something. So that's a reasonable answer. It is, in fact, the correct answer. And we're done.